Hi everyone, back again. So a little break there, moved into my new place and got some stuff set up. So this is the magnifier that we had running before, and got circuit running here, running about 10 milliamps, give or take. And again, I'll adjust it here. So as I make that same adjustment, the light responds like this. Okay. Anyway, so it's running pretty good. Made a few little changes, just sort of trimmed things up a bit, and got a analog milliamp meter, so matches bang on with the oscilloscope and voltmeter in the past, reading across the shunt there, which is carbon resistors instead of wire wound, so that they have no inductivity. And there's 10 ohm in parallel, so it gives me a very accurate 1 ohm. Got that idea from backup CPU, and pretty much the same circuit as you'd seen the time before. Right now it's sort of with the ground it gets a lot more intense, but right now, just without a negative to ground bond, it seems to be going pretty good, and the current seems to be more stable. So anyway, I'll show you the with the ground on here. So I'll have to tune it back in. Actually, yeah, we're still around the same current draw, so not bad. I turn it if I pull the ferrite in or out too much, you go in or out of resonance, so right about there. Okay, so pretty much the same with or without the ground on there, so yeah, things are going pretty good with this guy. Just getting this tuned back up for transmitting across the room with this 40 gauge wire across the on the same collector connection there. And so I'll just make this a little more streamed. For this, I'm going to take off the ground, and it just seems like if there's a ground connection here, it doesn't transmit as good as well to the receiver. And just take me a little bit here. Anyway, we've got this 40 gauge wire coming up onto the ceiling and all the way across the room. So onto the ceiling up here. Whoops, over here. I couldn't see it. And then we're just on this lead here. The transmitter is way around the corner. Kind of see it. There we kind of go. Okay. Anyway, so we've got our receiver here, and I've got the capacitance across the primary, the collector from the other circuit running up here to a known location, and we've got the LEDs going here. And so we can kind of adjust, you can see if I get my hand too close to this thing. Away, too close. away. And so the plate, in a way, adjusts that that difference in capacitance when it changes with nearby objects. So I'll move the plate a bit closer, and the ringing goes away, and then I'll move it further apart. Starts coming back. Too far. So I'm going to back up closer to it again. And then what happens sometimes is you gotta kind of get your hand, tap it a bit, and then we'll back up again slowly. Too far. It's like it needs to get drawn somewhere. So you gotta kind of start her up. Okay, so that's going pretty good. And how many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 LEDs. They're all 1.8 volt. Okay, so got this set up right now. Didn't want to waste too much of your time. So we've got the receiver running here. And this is pretty intense here. So anyway, we've got opposite wound receiver, opposite wound secondary and primary, or I guess you could say a step-down transformer in this case. And we've got the lights taken off here with the disconnected wire, but the tuning had to be adjusted. So now we've got our 48 lit up here. And so I'll change the capacitance here across the primary circuit. Let's just call it the primary, the low turn coil here. Yeah, and it's pretty sensitive. I'll get my hand close to it here. So that intense electrostatic field just needs retuning when stuff gets up to it. Ultimately, if it can't ring freely, it's taking away from the system. So we'll let it do its thing and just what you need. So what was critical on this, still got it fed by this the little wire here. You can probably see going up, that 40 gauge wire. So hanging in the air again, and everything there. So what was critical though was the output on the load, that connection here. So I just got a spooled up, it's running down to this green cable here. Can't really see it, but here's the end of it. It's just free. And I'll take off the ground here. Let's just call it the ground. And our light is gone. So it had to have some kind of ending impedance that continued on past it. And so we'll just connect that back up. I can do this with one hand. Let's flicker in here. Okay, good enough. Got our light back. So anyway, doesn't seem to be any loss running all the way down across the room to where you see the transmitter down there. Still setting everything up. I got lots in boxes here still to go through, but just wanted to make a new video. And actually we've got something else that's pretty exciting back over here. Okay, so what we've got here is the LMD Eric Dollard setup. And so we've got our different stages going down the line with the coils in shunt and capacitors in series, and transmitting through the dielectric rather than the electromagnetic path. So we've got our light here. Okay, and this is why I didn't have the oscilloscope on the other setup there. I just wanted to pretty much shown all the waveforms. It's resonating about the low 300s in the kilohertz. So yeah, we'll just leave that one going. Maybe we'll just check it again here. Still in and around that 10 milliamps. And so you can kind of tell it's working, because if you're not near the receiver you can't really see it, but you'll get that feedback LED lit up. And current should be the same as when we were over here. Did have to adjust a bunch of stuff on the other side, capacitance and plate spacing and everything, so yeah, I can still get that probably tuned down to where the transmitter was here. Anyway, so yeah, we'll leave that one going here, just where it was. Maybe go back to that later. Okay, so this was actually a kind of interesting idea I had, just to build the same circuit and little different coils, and then vertical resonator, totally kind of decoupled from the primary secondary. And again, this is where the real rise would start to take place, rising up this series LC resonant circuit. I had the original top load on top of here as well. Anyway, regardless of what I tried to do with input choking and everything like that, I couldn't get the current down to what was acceptable. So this primary secondary might not work. I really wanted to use these B&W coils. I'll turn the light on here. So we've got the Barker and Williams helical resonators made for radio, ham radio transmission type stuff. So anyway, not too big of a deal, but we'll go over here. So we've got our LMD circuit going really well. It's at about 526 kilohertz, just on the crack of the AM radio band. And yeah, you can even made sure there's nothing really going on that station, and when I turn on the system, just with the little radio here, you can hear it go clear instead of crackly. So anyway, it's not sending out noise, it's sending out a very clean signal. And so let's get the oscilloscope set up. So let's go and zoom in here. So we've got our oscilloscope across the input. Okay, so what's going on the input side? So looks like pretty stable square wave, 1.53 volts RMS across the input. This function generator was pretty old, but it seemed to work better than the newer digital ones. This is an analog type thing. So I can tune up and down the frequency here. Okay, so what do we got? So that same 1.53 volts across the input, pretty distinctive square wave. Okay, so now Gonna just move the oscilloscope leads off of here. I'm not gonna waste too much time by going all the way up and down the circuit, but we'll attach those across the output. So across the positive connection, and then just can't really reach to that across here, so just gonna go up here. So our light, still good. Might have to retune a little bit for the dampening of the scope reading across, but yeah, you just retune for it. So now we're gonna zoom in here. Okay, so got it found here. So we're at basically 500 kilohertz on the nose, actual frequency measured, and so pretty clean sine wave here. And so we've got, some excellent light. We've got 1.5 volts coming in. And again, these coils are all in shunt, all separated by capacitors. We're hitting it with a square wave coming in at 1.5 volts RMS. Got this strange increase. The bulbs don't light across the input, which is interesting to note. I'm going to take off the positive here. And so our connections are made to the negative input, positive input. I'll go back around some frequencies here, see if we get anything. So that's the range that we were around here, so bring it back to about what I had, which seemed to be closer to 500, and watch the waveform. So we're still putting out, and the scope's reading across the output without the load, basically. So anyway, we will just reconnect these to the output. So we bring it here. Still nothing. Move it down another section from here to there. Starts appearing. So as we get further from the source, magnetism and dielectricity start to appear. Pretty strange. Get it across that one. And this is our setting. I'll just retune it again here. So, oh, and I gotta move that, can't cheat and hook up to the source, right? Okay, so, just retune that up a bit. And we're back, 510, waveform. Camera can't really adjust. So we'll get it real nice and tuned back. Super clean. Get that little peak right on the tip. But what gives? We're reading DC. And we're on the DC reading, just like we had been. Except now we've got this perfectly clean sine wave instead of a square wave. And so where does it register? So we will start going through it here. So 4.9 volts reading DC though. So due to it being AC, let's read what the peak to peak is. 14.5 volts peak to peak. Not bad for a 1.5 volt square wave going in to a dead end capacitor, right? So, pretty happy with that. So being around that frequency, I can design a magnifier that the primary reacts to that frequency and build the feedback circuit for that particular frequency here. And obviously start off with a resonator that resonates at about 500 kilohertz, so that would be pretty cool to drive it on 1.5 volts, putting out a little bit extra out the other side here. Okay. So, no transistors, no funny switches, just analog in and out. So, we'll talk to you guys later. Oh, and real quick, I just wanted to show from down here, we've got our receiver going. It's kind of buried behind a bunch of crap down there, but I'm gonna go ahead and retune the feedback circuit. Put it out of tune, back into tune, too far above tune. Yeah, so going pretty decent. And we've got our current draw just on 10 milliamps there. With the two receivers, they are, well, the sender and receiver with having the plate, because it will actually still transmit without the plate, but it's really, you can really get it tuned in with that on the side. Otherwise, the transmitter doesn't really need that tuning plate, but it's handy when you can match it to the other side really easily. So, yeah, pretty interesting stuff. Gonna be moving on more. Obviously, just putting together stuff that I had from the past, but want to put the Don Smith thing back together using these $500 coils. Again, they're B&W coils, and definitely pretty excellent. Anyway, we'll talk to you guys soon. Thanks. Bye.